Yay!
Yay! All right. Now let's treat the more general situation of a projectile in which the launch platform and where it lands are not the same height, right? This is the more general thing. What we've done before is that it lands the same place where it takes off, the same height where it takes off. So let's see how this is going to work. So maybe I'm launching from like a cliff, right, at some angle theta with respect to the horizontal, and then it's going to land at some distance at the bottom, right? I want to find out what r is. So as usual, I'm going to start off with my two equations, one in the x direction, which is the easy one, and one in the y direction. And the first step always in these problems is how long is it in the air? How long is it flying? And so always when we do that, we're going to want to know from that equation what t is. I want to solve for t. That is the question. Okay, so I don't know. Let's put some numbers in. So let's say VI is 80 meters per second. So it's going pretty fast. So VI, oh, and theta, let's see, what theta did I use? 30 degrees, our standard 30 degrees. So VIX is 80 cosine 30, and that's going to turn out to be about 70 meters per second. I'm going to approximate stuff. It's not quite that, but it's close enough. Let's just use round numbers. You can use your calculator and get the right one. But this is pretty close. VIY is 80 sine 30. Sine of 30 is a half. Remember, put that in your head. That's going to be really, really useful. And so this is going to be, well, it's not even approximate, it's exactly 40 meters per second. So in the x direction, we're going 70. In the y direction, we're going 40. And let's say that we are at delta y. Ooh, let's be careful. How high is that cliff? I'm going to say it's 45 meters. But 45 meters. Well, let's be careful. Delta y, right? This is where the physics setup becomes really important. Delta y is final minus initial, and it lands at a lower point than where it takes off, right? If we call the bottom the ground, if we call the landing point the ground, then that's going to be y0, and y initial is going to be 45. So the delta, how much did we change in y? We went down, right? So delta y is minus 45 meters, right? If delta y is plus, that means we shot up and hit a target above the ground. So those signs are going to become important. All right, so now we know everything we need to know to solve the problem. So let's figure out how long it's in the air. So I've got minus 45 is equal to VIY. Let's see, what's that? 40 times t. Minus half a g is 5 t squared. Okay. All right, that's a quadratic. And remember, the advice is always make that coefficient in front of the t squared, make that positive. Let's bring the 5 over to the other side of the equation. That'll make things easy. 5t squared minus 40t minus 45 equals 0. It's going to be a lot easier if we just factor that 5 out. We don't need it. So t squared minus 8t minus 9 is 0. Cool. So that's ready. That's ready to go into the quadratic formula. But maybe you remember from some algebra class, always take a look at it and just see if it's something you can factor easily. It turns out this one is. This one I could say that's t minus 9 and t plus 1 equals 0. So I factored it easily. So t is 9 and minus 1 seconds. Those are the times at which it is at ground level. Well, minus 1 seconds, that's not physical, right? That means it was at ground level minus 1 seconds before we launched it. So that would have been, if we would have continued the path down here, that would have been back here, right? Well, the math doesn't know. Mathematics is kind of dumb, and it doesn't know the physics. It doesn't know when we launched it. All that's saying, all you're doing when you're solving the quadratic is solving the parabola. You just want to know where the parabola intersects the ground. And so it'll give you 2 points. But it's up to you to figure out if those points are physical, right? If it makes any physical sense. So minus 1, we hadn't even launched yet. So no, we're not going to use that one. So t equals 9 seconds. It's been in the air for 9 seconds. Okay, well, that's just about it, right? Because now then the range is just going to be Vx 70 times those 9 seconds. Every second it went 70 meters horizontally, right? So this is going to be 630 meters. Boom, is where it lands. So we've solved this problem much more generally. I've solved it for launching it above where it lands, but notice this technique solves basically every launch problem. So we're kind of done with the whole thing because I can launch from the ground up to some point, up to some target, and this handles that perfectly well. It's just that now the delta y is positive instead of negative. So now we can launch from any point and hit any point, and we know the techniques to get it. So now we've just sort of solved every problem where we want to find the range. We're kind of done. That's nice.